Can Samsung handle Musk's chip orders? Can Musk build his own fab? The two most realistic questions in the AI era. In the age of AI, chips are no longer just hardware components, they are strategic assets. When Elon Musk began shifting high-end chip orders to Samsung Electronics while also signaling ambitions to build in-house chip capabilities, the semiconductor industry started asking two critical questions. First, can Samsung truly handle these orders? Second, can Musk actually pull off building his own chip production capability? These questions reflect two different dimensions: short-term execution and long-term strategy. 1. Samsung, technically capable, structurally constrained. From a purely technical standpoint, Samsung does have the capability to manufacture advanced chips. 1. Leading-edge process, one of only two players. Globally, only two companies are capable of producing cutting-edge nodes, such as 3 nanometers class processes. TSMC, Samsung Electronics. Samsung's adoption of GAA, gate-all-around, architecture represents an attempt to leapfrog in process technology. This leads to an important conclusion. Samsung can manufacture advanced chips. The real question is how well it can do so. 2. Yield problems, the real gap. In advanced semiconductor manufacturing, success is not just about production, it's about yield and stability. In recent years, Samsung has faced lower initial yields at advanced nodes, reduced customer confidence. For AI chips, this is critical. Low yield right pointing arrow, higher cost. Instability right pointing arrow, unpredictable delivery. However, this creates a counter effect. Samsung is more willing to dedicate resources to optimize production for major clients. If the client is Elon Musk, priority allocation becomes almost guaranteed. 3. Capacity and structural limitations. Compared to TSMC, Samsung's challenges are not purely technical. Smaller leading-edge capacity, less concentrated high-end customer base, resource competition across logic, memory, and packaging. AI chips also depend heavily on advanced packaging and HBM memory, areas where Samsung has strengths, but also internal resource trade-offs. Summary: Samsung's real role. Samsung is not a replacement for TSMC. Instead, it plays the role of a critical second source. Its strategic value lies in enabling customers like Musk to avoid total dependence on a single supplier. 2. Musk, capable of designing chips, not necessarily building fabs. If Samsung's question is about execution, Musk's question is about scope. 1. The reality of building a fab: money is only the entry ticket. The cost of building a leading-edge semiconductor fab: $20 minus $30 billion, or more. But capital is not the main barrier. The real challenges include EUV lithography ecosystem, decades of process know-how, extremely scarce talent, deep supply chain integration. Today, only two companies can consistently operate at this level: TSMC, Samsung Electronics. This is not an industry that newcomers can replicate quickly. 2. Musk's core strength: integration, not fabrication. Looking at Musk's track record at Tesla, vertically integrating batteries, software, and manufacturing. In aerospace, restructuring supply chains and production. His strength is not inventing industries from scratch, but reconfiguring existing industrial systems. 3. The most realistic path: design control plus outsourced manufacturing. A proven model already exists. Apple designs its own chips, A series, M series. Outsources manufacturing to TSMC. Advantages of this model: control over performance and architecture. Avoidance of manufacturing risk. Stronger bargaining power. If Musk builds chip capabilities, this is the most likely approach. 4. Why Musk might still move toward partial manufacturing. Even if full-scale fab construction is unlikely, partial involvement is possible. Investing in existing foundries, securing dedicated production lines, partnering with governments. These approaches increase control without taking on full manufacturing risk. 3. The real issue: control, not capacity. When viewed together, these questions are not just technical, they are about power. 1. Why diversify orders? Because AI chip power is highly concentrated. Design right pointing arrow NVIDIA. Manufacturing right pointing arrow TSMC. This means pricing, capacity, and timelines are controlled externally. 2. Why build in-house chip capability? Because in the AI era, compute equals productivity. Chips equals control. Without control over chips, even the most advanced AI systems depend on external infrastructure. 3. Samsung's strategic value. Samsung's importance is not purely technical, it is structural. A lever to break monopolistic dependency. Conclusion: short-term diversification, long-term control. The entire strategy can be summarized in one line. Short-term: use Samsung to reduce risk and improve bargaining power. Long-term: build in-house chip capability to control compute. Samsung can take part of the load, but not all of it. Musk can build chips, but not easily replicate a leading-edge fab. What is unfolding is not a simple corporate competition, but a structural shift. From depending on supply chains to controlling supply chains. In the AI era, the ultimate competition is not about better models. It is about one thing: who controls the chips?